Time for the second presentation. So the second presentation will be given by Jullia, who is a senior machine learning engineer at Fandom. And she will present us ways to scale up machine learning experiments on AWS. So floor is yours.
Thank you, thank you. So I generated this with AI, and there is an AI watermark in the title, so I love it. Not to mention the amount of legs some of the pugs have, but it's especially for this meetup. Yeah, so let's get started. A few words about me. I worked at the ML engineering team here at Fandom. It was formed only 2 years ago, and it was around since I joined this company. We work closely with data science team and data engineers team. I'm also a member of Women in Machine Learning Poznan chapter. My hobbies, outside work, I play bass and sing in a band. And again, just for this meetup, this is my MOPS. It's not exactly a pug, but also very sweet. And a few words about Fandom. So Fandom is the world's largest wiki fan platform. If you ever Googled something about a fictional character and you ended up on something like a colorful Wikipedia, it was probably Fandom. Like here you can see an article about Geralt of Rivia. And Rivia, what did I say? We serve 350 millions of fans per month, and there are more than 40 millions of pages of unique content on this platform. And we serve hundreds of thousands of fan communities. And Fandom is not just this wiki platform. There are more entertainment-related platforms, as listed here on the right: GameSpot, Metacritic, TV Guide, Fanatical, and Giant Bomb, where you can find reviews about games, about movies, where you can purchase a game, find a game guide, and so on. So let's start with the motivation. Why I find what I'm about to share with you is important. So the why. And talking about the MLOps, a term that emerged like not so long time ago, many companies found themselves in a complete greenfield, like there is no MLOps yet. And yet we're all dreaming about this ideal MLOps platform, like this futuristic, sustainable city where everything is monitored, tracked, automatically deployed, versioned. We have all the feedback loops, automatic retraining, efficient serving. We don't pay too much money and so on. But the reality is many companies find themselves somewhere in between. So you're still prototyping with your AI ideas. You have a lot of prototypes, and the MLOps platform is in progress. So I call these growing AI organizations, and my opinion is there is a special need for such cases to enable AI at a large scale, and this is why I call it large-scale ML experiments. So on purpose, I'm not using the production yet because it's a large-scale experiment. And in early MLOps / intermediate MLOps, maybe every solution design requires consideration of what tools, architectures, infrastructure is already available. Like what should you do if there is no MLOps platform? How big is your ML engineering / MLOps team? It's also a valid concern when you're about to plan a project. What's the solution maturity level now, and what are the perspectives for the future? Like, is it a blind guess? We just need to check it out on large scale, or it has perspectives for a longer term usage. And importantly, how to avoid overinvesting and focus on what truly matters. And what's under the hood? I guess frustrated engineers and too many questions on Meetup. Do you have it on production? Not yet. It's all, it's all too fresh. It's too new. There's too much hype and so on. This is the MLOps, so I hope everybody has experienced that. And now for the how, for the large-scale ML experiments, my favorite answer is it depends. And in this case, it really depends on what we need. is variety of tools and a mindful approach. So if you have too simple of a tool, you're going to be too slow, you're going to waste too much time. And if you pick a tool that is supposedly solving everything, and there are many ML frameworks that say they will fix all of your problems, but in the end, they're not useful for any of them. Yeah, I'm a little bit pessimistic right now. And yeah, I couldn't skip the famous MLOps landscape visualization just for that. So we need to find a sweet spot and be a little bit of a critical before we invest too much time into this like Guinness World breaking multi-tool. It's the largest one you can buy. Okay, so for me to demonstrate you how, we're gonna talk about 3 success stories at Fandom, and behind each of these there will be 3 different designs, each on the AWS. And we're going to go through different like abstraction layers. There will be 3 projects, and we're going to use AWS EC2 for the first one. Then we're going to pick serverless, and finally Sagemaker framework. And whether these 3 are going to lead us to this like final form of a human brain, we'll see, or maybe we already know. Maybe we already have opinion on these. Okay, so let's go save the world with the MOPS, like this one. Okay, so let's start with the first project that will utilize AWS EC2. And we have a quick answers project. So on some Fandom pages, there are like Google style quick answers that were generated with OpenAI, I suppose, and is backed by a RAG system as well. And there is a special process for rolling out the quick answers in collaboration with the community, with the editors that are creating the content. And this is why we need to generate text embeddings for selected wikis on demand and ingest them into the RAG. So as short note, you already know we're going to use EC2, and probably you all know what EC2 is, but just to make sure, EC2, Elastic Compute Cloud Infrastructure as a Service. So it's like the key product of AWS that lets you provision and use virtual machines in the cloud. You can choose among hundreds of instance types that support different workloads, run on different hardware and operating systems. There are many families of EC2 instances that are optimized for network traffic, for storage, for compute. There are many different EC2s for GPU workloads and so on. And this is all at the infrastructure level. You pick an instance type, you check all the specifications, including the GPU architecture you might be interested in. And there is nothing like an application layer. You just provision it, you enter what you just provisioned, and you can deploy anything in any language that you want. And like the very basic feature for setting this up is user data bootstrap script that will control how you set it up when you launch it for the first time. And for very important reasons, for being able to generate the embeddings for any model from the Hugging Face that we would like to, no matter what, CUDA drivers it requires, and like next to other libraries that might speed up its inference, we're going to simply distribute the embeddings generation workload on GPU-powered EC2s like G5, 8x large, maybe just 10 of them or 20 for highest possible level of flexibility and control. And then you know just to orchestrate the tasks, we are going to use the SQSQ, another AWS service, which is like a simple queuing mechanism. And again, apart from the infrastructure, it's all on us to implement after the embeddings were generated, whether we store them on S3 or EFS in AWS. It's all on you. And we're going to use this technical table just to illustrate the engineering effort required for the EC2 is the highest engineering effort among all the choices. So all of these are with red. Yes, I'm assuming you might not have time for all of these, but this is like this reality. So you need to select the infrastructure, you provision and free resources on your own. If you don't free them, you pay a lot of money, and you also it's not ecological at all. You need to handle the success and the failure. You need to know when it happens, because AWS only gives you the infrastructure, not to mention distributing the workload, monitoring what's going on inside provisioned resources. All the IO operations and parameterization are also to be implemented by you. There was no mention about the application logic just yet. So with all of this, when would you use it? EC2 is basically a remote machine, and it also means it minimizes AWS abstract layer. So you're as close to provisioned hardware as possible. And from here, it comes like a great advantage. It maximizes flexibility, control, and changes to set up cutting-edge tech, like efficient GPU model serving. For other AWS services, maybe you need to wait for them to become supported. And the cons, as big as the flexibility advantage, there is the biggest implementation and operational overhead. And due to this overhead, if you cut the corners too much, it can lead to resource waste, unwanted costs, and there will be challenges with long-term integration into automated systems, because you need to implement everything. Even if you decide to pick like a ready-to-use tool, it's on you to install this tool and then to update the tool and so on. So because of this, let's now move to the second project in which we're going to use AWS serverless. And this project, I call it an installment mapping prototype. And we have like a completely new idea for how we can map, for example, Geralt of Rivia to all the installments in which he appears. So he appears in the Netflix series. By the way, did you know there is a first look for the new actor that will replace the previous one? I had to tell you. And all the games that Geralt of Rivia appears in. And we need to do a lot of complex logic to associate this guy from Fandom platform with entries from external DBs. And we consider this project like of a high ambiguity. There is like a hope, there is a perspective for a very huge win if we manage to do this. But apart from that, there are very challenging solution requirements. We'll have to combine a lot of different input data sources. All the algorithm logic will be formulated as we iterate on it, and so on. So this creates the need to iterate much faster than we would on an EC2. So quick note on serverless, I talked a lot about what EC2 means. And now for the serverless, AWS Fargate is an example for the serverless backend. You just imagine there is no such layer as an EC2. All that we're going to do is to define memory and compute resources required for our applications, and you need to worry. You don't need to worry about like what's underneath. So even visually, there are less steps to ship your application. And also, right now, we're not going to pay for EC2 instances. We're only going to pay for the requested compute resource when they are used. So for this project, it's very complicated. I try to break it down into something simpler, but let's just keep it, high level, and we can continue at the networking maybe. So we pick serverless, especially for this project, because we want to be fast, we want to scale up fast, and we want to iterate many, many times before we reach the final form of the algorithm. So we pick Fargate, the serverless backend, and we pick AWS Batch, the simplest way to run Dockers on AWS. So when we first started to develop, we've been submitting thousands of AWS batch jobs. Every time, every job can be assigned a maximum of 16 virtual CPUs and maximum of 120 RAM gigabytes memory per task. First submitting from a computer, and then we eventually turned this manual step into another job that I call submit and observe job. And this is to show you the flexibility, apart from the fact that it's a Docker application, you're not limited to anything, like the app can do anything you want. And so by this, like one smart trick, we'll be also able to integrate this into an Airflow, because we know we're going to need the data refresh on a weekly basis. And what the Airflow DAG will see is just this single submit and observe job. All the other ones are happening under the hood in the batch compute environment, and it will also report the success, which makes it compatible with Airflow. And there's also this dotted line to CloudWatch, because if your Dockerized application is doing any kind of logging, it automatically ends up on CloudWatch, which wasn't the case for the EC2. Okay, so now back to this technical table. There is no selection of underlying infrastructure anymore, and you don't provision and don't have to free the resources. It's automatic. And you also get success/failure report for free. You're still are responsible for distributing the workload somehow. This is not included. It's just like the serverless for the infrastructure and nothing more. You will see very soon. And like, as I said with the CloudWatch, you don't have to implement monitoring unless you need something like customized. And still, I/O operations is on you. The entire application logic is on you. And there is a very nice support for parameterization, both through environment variables and parameter templates as well. So there is no here with a star, because it kind of depends on what you need, but it might be just enough. So wrapping this up, advantages of AWS serverless: no infrastructure to manage means you can focus on application logic, and it gives you a faster development cycle. And it's like one step further into the AWS world, which gives you out-of-the-box integrations and features like CloudWatch logs, monitoring, parameterization support, and setting timeouts. So if you're not sure about your algorithm and you want to kill it after 60 minutes because maybe it's stuck, you just set the timeout, and it will fail, and it will fail. It's portable, it's based on Dockerized applications, cost efficient, and still highly customizable. So, the engineering effort is somewhere in between what we're going to see on next slides. And the cons: very sad thing, no serverless GPU yet. We're waiting. There's no such thing on AWS outside. I know there's something starting to pop up. And just some strange caveats, like bad jobs history expires after 7 days, which is not that convenient when you're operating in this experimental mode and somebody asks you about the bad job you ran for them like a month ago, and it's gone from here. So you need to do something if you want to be able to tell how long it took, for example. And the debugging is, in theory, more challenging because there is a level of abstraction for the infrastructure, but it's hypothetical. I never faced any of these kind of challenges, but it can happen. Okay, so last but not least, we need to talk about AWS Sagemaker, the product tailored for AI by AWS. And for now, for this case, let's consider building fundamental article tags for ad targeting. So we have 25 millions of articles with multiple BERT-based models to classify. And this time, let's say we want to use AWS managed solution to minimize the engineering overhead and speed up the delivery as much as we can. And just to tell you like what the project was about, it's a simple classification like to tell if a page is about a character, if it's Geralt, and that it's connected to games, movies, and books, and so on. So as I said, fundamentals. And we are going to pick AWS SageMaker for that, specifically SageMaker models for inference, and more specifically SageMaker batch transform for quick and robust solution for multiple models and runs. So in this case, we're not building the entire application at all. This slide is pretty packed, but it contains everything you need to get up and running with SageMaker in theory. You prepare the model itself, the SageMaker Docker image. Then you implement the inference script that only contains of 4 functions you need to implement. And then you use the Python SDK, for example, to submit the batch transform job. And just by specifying input path and output path, only S3 is supported. You also specify the instance type, which looks like an EC2 name, but it has to be a special EC2. And you pick the instance count. It will create the entire job for you. So if your S3 path is a directory of files, it will traverse automatically. You don't have to implement that. And it will also automatically write outputs also to S3. I don't think anything else is supported. And it also comes with all the monitoring in place, and it can even report the success with the green color and failure with the red one. So it's all like shiny and great. So, and so far so good, engineering effort is lower on this table at least. You need to select the underlying infrastructure because there are these EC2s, as I told you. So they have to start with ML. And apart from that, SageMaker will provision the free resources for you. It will tell if it was a success or a failure. If there is at least one file that couldn't be processed, it will fail. The workload is distributed automatically. You don't even know how this happens. And the monitoring, including monitoring GPU matrix, is there. You don't even have to implement the S3 read or write operation, neither the parameterization. It's all in the same box. So the advantages of SageMaker are that it comes with an interface, base Docker images, a number of jumpstart examples, and it means you're not starting your ML app from scratch. And sometimes, it's very important. Maybe you're just a single ML engineer in the team and you have to scale up somehow. Maybe it's a good choice then, because it is end-to-end. As I already told you, there is no need to implement any of these that we had to do for the EC2 or the serverless case. And most CPU and GPU workloads are supported. And then now for the disadvantages. So with this like super shiny interface comes limited flexibility, and now a very important thing to note: the longer you use it, the worse it gets. So eventually, all the like corner cases start to pop up, and SageMaker can do nothing about this. It's just not flexible. And you have to decide if you're just going away from this, or you start adjusting your pipelines so that you keep using Sagemaker for a longer time. And I even think that it can lead to poor architecture decisions just because at first it's so fast and then it's getting worse. Troubleshooting, nearly impossible. You just don't know how it's happening, but it works. And it's more expensive because it's for AI. Recently, they renamed AWS SageMaker with AWS SageMaker AI. So this slide is outdated. And you know, these are the kind of updates that they're doing. Yeah. So a little bit of my frustration because we've been using it for 2 years. And now for the wrap up, Pag Rolo in a rainbow. So just to wrap things up, I hope you got the message, but just to solidify it, we've seen EC2 giving us the most control and flexibility, the lowest level of abstraction. Maybe it's good for your engineering style if you don't like all this abstraction I told you about. And the dependence on AWS is as minimum as possible. And it also means highest engineering effort, highest time to ship if it's supposed to be a robust solution. It doesn't integrate automatically with anything. On the other hand, it's flexible. You can integrate with everything, but you need to do it yourself. You need to maintain it yourself. And I think it needs expertise. It needs more than AWS SageMaker, for example. Serverless is somewhere in the middle, and we've seen a serious disadvantage, lack of GPU support. And for the SageMaker, I put 2 warning signs because it seems like there is lowest time to ship and lowest engineering effort, but sometimes you just can't find the information you need anywhere in their documentation. And then I don't know if it's if this graph even holds. So if you're following their lucky path, it's very fast. So summary, important thoughts on the closing note. We've seen how different projects require different approaches to successfully deliver AI at scale while you're heading towards advanced MLOps. And the cloud, such as AWS, is full of possibilities. And by learning its capabilities, you can develop and deliver as fast as you need. And you need to choose wisely. Don't reinvent the wheel if you don't have to. And don't over-engineer. And last but not least, what's next? I showed you 3 projects. 3 were just using completely different patterns on AWS. So I believe next for us will be unified platform. And after enough of large-scale experiments, you finally know what you even need for your MLOps platform, and you will be ready to decide if you're gonna use a third-party tool or just you build your own, whatever fits best. And this is all I got for you. I hope you learned something. Thank you.
Thank you very much for your presentation. Are there any questions?
Okay, so first of all, great presentation. And my question is with the SageMaker AI, and it's about support. So basically, were you able to get any meaningful support on the tool from AWS?
Like through the customer support, you mean?
Well, like technical support on the service itself, like ticketing or anything?
Oh, yeah. Good question. I think we all know the answer. Yeah. Sorry.
Okay. So maybe
I have to say it's not very easy. You can get some information. I suggest you list all the docs that pop up on the Google search. You tell them you already read these, and you're one step further. But yeah, it can get very, very tricky, and there's the trade-off of using managed frameworks.
Okay, so my follow-up question is, because this is something that I think nobody is going to actually be able to see unless they work at least 2 years on this stack. So have you seen any improvements in the services over the 2 years, besides the names?
The improvements. I didn't prepare like for the positive side. What I can think of now is like the base Docker image for CPU is Python 3.8 and it's reaching like end of maintenance. But yeah, it is faster. So Jacek, the manager of our team, is mentioning a slightly different service, not for the like batch transform, but for the Jupyter Lab environment for data scientists and so on. And they are making it better. They are making it faster and so on. Maybe it has more users than the batch transform. And you know, they're also like kind of keeping up with the hype. They kind of forgot this Python 3.8 was running on CPU nowadays anything, right? So they're keeping up with the trends. They have a lot of jump starts for LLMs and so on. So you need to remember it's their product for AI. It's important to remember.
Yeah, yeah. Thank you very much for that.
Thanks for the presentation. So I have a question because for the big machine learning models, it usually requires, a lot of GPU memory. So for the serverless resources, there is the problem that they usually doesn't support, the GPU. So, but on the other hand, when we are using EC2 or Sagemaker, it usually has to, run all the time. So you are paying also for the time that you are not processing anything, and the client would like, only pay for the time when you are really calculating something. So do you see maybe, or in your company, what's the best way that you see to optimize the costs, to have some, balance between the costs and the using GPU and, hosting the models to not pay for all the time for the resources, but also, be able to host the models. So do you have an approach?
Yeah, just to follow up to this, do you need like continuous serving or is like periodic usage?
Like it's
and
periodic,
then it's
so
idle?
so the client send some request and want to just get some answer, but then we can just turn off the resource.
I would. For what I've seen, we're not hosting large language models ourselves right now. But for this case, if you worry about like machines being idle, for the same AWS batch service I showed with the serverless backend, you can use an EC2 backend. And this will ensure if the machines are idle, it will terminate. So I would use AWS batch with EC2 if that's possible. And with EC2, it means you can build the compute cluster out of any instance types that you can get. And for example, Metaflow framework can be deployed on such a backend batch with EC2. Exactly for these reasons. So I'll give it a try.
Yeah, I think that sounds reasonable. And sorry for the tricky question.
No, it's not tricky. It's a good question. And I will go for batch with EC2. Yeah.
Yeah, hi. I would like to go back a bit to the Sagemaker. You mentioned that you faced some issues that were hard to solve or even impossible. Can you provide some examples of that?
Yeah. How to make this quick? Let me see. So part of this installment mapping, for simplification, I told you that everything was on serverless, but there is a number of components there. And part was using the Sagemaker batch transform. And we were told to scale a new model from the data science team that was using like transformers underneath and loading a lot of like dictionaries into memory and so on. And it was very memory intensive. And it was the first time the model was so big, but it was running on a CPU. And it's just, strange things start to happen, like the packets from S3, your input data arriving to the batch transform server, but it's not complete. Like the data gets truncated and it looks very strange errors. And then you basically, the way to solve this is like completely non-intuitive. You need to adjust their retries mechanism and you need to follow their troubleshooting. That will not give you much of a hint why it even works to me. Like we really tried to make a deep dive, and I don't think we solved the mystery. We fixed it eventually. But it's like you don't exactly understand what's going on. You find the troubleshooting documentation, and then you just get it sorted out. And it was at the level of how input data is sent to the server that it setups under the hood. And we couldn't reproduce it in any way locally. It's impossible. Because you don't know how it even loads the data from S3 and how it sends. You can't see it.
Okay, in terms of data loading, you have like two modes at least to upload data, because you can download it upload it at first, or you can use some kind of a reference to files. So maybe that will solve your problem.
I need to check. Yeah, we're only using a single strategy, which is like multiple files, and each file is processed at once. So we have data batched into these files beforehand. So for other strategies, I don't know, maybe they're not that problematic.
I don't know if it will solve your problem, but in case, if data is broken because of some problem with uploading, you can use, you have 2 or 3 modes to upload data to SageMaker instance.
Yeah.
So you don't have to upload it first. You can use it as a reference, so it will be uploaded during file reading. So maybe it will solve the issue.
Yeah,
Okay,
I need to check it out.
Besides this problem, anything else? Sorry, I'm asking because I have some quite short experience with SageMaker, and for me it worked quite well. So I'm wondering.
Apart from this, I need to think about it. Maybe during the networking phase, but usually the requirements that this imposes, like exact library versions that you need, makes it quite hard to extend. Like it's not impossible, but it suddenly requires some expertise about the SageMaker. So you stop using SageMaker, you even lose all this like precious knowledge. That's what I wanted to emphasize. You need to mind if you want to invest in it. If you want to extend the Docker image, you need to get your hands dirty, I would say, and you need to look around inside the Docker image yourself because it's not documented. So maybe you're looking for this single parameter that needs to be adjusted only in this certain PyTorch based SageMaker Docker image. It's hard-coded. It's hard-coded somewhere, sorry. And you need to find it. And it's like, you have a senior ML engineer. Maybe they will find it and maybe not. And if you don't, you're going to be stuck. You need to contact AWS support, I guess. So it is tricky because of the lack of control. But it also, as I showed you, it can get you up and running very fast. Problems start to show when your AI projects are getting like more creative. Then it appears to be quite limited, but it's still like good for the jump start. I don't know if I convinced you.